been doing this for a long time. I lecture in information security at UCID. It just came from my lecture actually, and at UTS. I'm doing a PhD in blockchains, funnily enough, really looking at this Ethereum stuff. I used to work at Freelancer and on startups and stuff, so nerd through and through. Right, so Bitcoin is the thing we all heard about. We all know what Bitcoin is, or we should know what Bitcoin is, at least at a high level. It's this cryptocurrency that lives on the internet that everyone seems to want a slice of, right? Came out in 2009 by this fella, who's probably actually not a fella, Satoshi Nakamoto. You can't really see my footnote there, but basically he's a pseudonym, right? Nobody knows who Satoshi Nakamoto is. He's just that guy. It's open source, so he published this really, really good paper, like very concise, excellent academic paper from no university, just on the internet. And he wrote the software, the first client. He also then started the first client, mined a bunch of, and basically mined a bunch of the first Bitcoins. It's worth real money now. It was at the peak, it was worth over $1,000 US, so about 1,300 Australian. That's what my mum bought in. But that was my bad advice. Now they're worth about 414 US. I looked this afternoon, they're 555 Australian. So they've been fluctuating between about 550 and 600 Australian for the last couple of weeks, which is a market cap of about 6.3 billion US dollars. So that's nothing to scoff at. And there's some info there. How to get Bitcoin? How do you get Japanese yen? You go to an exchange and you say, here's my money, I want other money. Right, that's exactly what you do here, except it's a little bit quicker to get the other money, and it's digital. There's no cash equivalent of it. BTCE, that's the old school one. They've been around since the beginning, almost as old as Mt. Gox. Mt. Gox was a famous exchange that came out in the beginning, originally designed to trade Magic: The Gathering playing cards. If you know that ultra nerdy game, basically it's dead now. They got hacked. Bad, lost all my money, and my brother actually lost a few grand in that. I think Paul lost a few grand in that as well. Yep, sucks to be you. So nowadays there's a bit more modern. CoinJar, this is, they used to be based in Australia until our government decided they had to charge GST on Bitcoins, and then they bailed from Australia, but they still work. You can buy Bitcoins with BPay on these guys. So that's a really easy way to get Bitcoins, not necessarily the cheapest. And then you can trade into Poloniex to do other stuff, which I'll tell you about later. What's a blockchain? Right, blockchain is basically these little snapshots in time, right? In Bitcoin, it's about a 10-minute snapshot in time, which is a collection of transactions, right? We'll come back to transactions in a minute. Data is append only to this blockchain. It's effectively a ledger, right? It's an append-only ledger, and unlike every other a ledger ever to be exist in humanity, this ledger is not run by a central authority. It's not run by the Australian Reserve Bank. It's not run by Deloitte. It's run by a distributed network of computers. Right? So it's the first time we found a way to have a ledger agreed upon by a distributed system that no individual controls, but the collective control via this mathematical algorithm. So basically, if I want to transfer money to you, right? I think we talk about transactions now. Yep. So I want to transfer money to you, it's basically a check, right? Nobody trusts checks, right? I'll give you a check for $100,000. You're not going to be like, oh, I've got $100,000, until you go to the bank and the bank spends a few days going, oh, yes, you have $100,000. In Bitcoin, that's basically what we do. I want to send $100,000 to you. I write a check, which is from Luke to you, this $100,000 signed by Luke. And then I publish that to the network. The network's constantly listening, waiting for these checks to come in. As soon as they come in, right, they validate it. The network goes, okay, does that guy have $100,000? Yeah, okay, it does. And is this signed actually by him? Yes, it is. Okay, cool, I'm going to include that in a block, right? Once that block gets solved by the network, right, that's then solidified in history. Each block, right, depends on the previous block, right? See here? They're all chained together, right? Blockchain, right? Funny that. And basically the further down in the chain your transaction exists and is accepted, the harder it is to change, right? So that's basically, if you have a transaction that you submit a transaction and it happened 5 blocks ago, you can be very sure that transaction has gone through, because it's very hard to go 5 blocks back in history and change that. Right, so we don't accept checks because we can't be trusted. We can trust a check though when the bank says that check is cleared, right? that's basically when you publish your transaction to the blockchain, you can trust that that money has been sent to you when the whole network includes your check, your transaction in the blockchain. Okay? And that's basically all it is. Right, so all Bitcoin clients are sharing latest blockchain chain information. So they've got this big peer-to-peer network. Every time you boot up the Bitcoin client, it's talking to other Bitcoin clients around it. Some of those clients are called miners. These miners, they're the guys that actually try and solve these blocks. And at the end of the day, solving the block is just this sort of check to prove you did a whole bunch of work, right? And as a collective, the whole network can do work at such a fast rate that nobody else can do work and beat their chain. Now, the details of that are a bit more complicated and I don't have time to go over it, but that's how it works, right? You can do your own research after that. New currency is introduced, new Bitcoins are introduced every time these guys solve a block. The reason they want to solve blocks, it's very computationally expensive. It costs a lot of electricity, real hard electricity, to solve these blocks. They're incentivized by a block reward, right? They get, the algorithm itself gives them new currency, right? And that's how new Bitcoins are introduced into the system. Okay, any questions on Bitcoin and blockchains? I know I'm screaming through this at a lightning pace, but I want to get to the fun stuff. Yeah?
What's the hard limit threshold for current technology of being able to mine Bitcoin?
What do you mean by the hard limit?
Is there a hard limit? Is there a point where it's the next block is so hard to mine that we don't have?
No, so the algorithm itself is actually self-adjusting. So it's a 10-minute block time. As the network speeds up, you would think that would reduce the block time. But the algorithm itself self-adjusts its difficulty to ensure that 10-minute block time happens.
Okay.
Yep.
Concerning the ledger, I imagine you start with the ledger, it's fine, you get longer and longer, but I imagine as you get longer and longer, the blocks get computationally harder and maybe the time transaction becomes really long.
It doesn't necessarily get harder because of this self-adjusting algorithm. So it reduces the difficulty to keep that time frame at about 10 minutes. But what you raise is a very good point, is actually a problem for Bitcoin, and that is that as you get this ledger longer and longer and longer, of course it's getting bigger and bigger and bigger, and the Bitcoin blockchain's at about 55 gig, is that right? 55 gig at the moment, right? It's not going to fit on your phone, right? Ethereum, which I'm going to talk about in a minute, is actually up to about 5, 6, 7 gig at the moment. So scalability in terms of disk use is actually a big problem for Bitcoin. There are some cool ideas out there, like you don't need to have the whole blockchain there at all times, but they're a bit more complex.
Is it possible for Bitcoin to adapt it?
Is it possible for Bitcoin to adapt? Yes, if more than half of the miners agree to adapt it, which is hard to convince them because they're mostly in China and have no incentive to change. If they have an incentive to change, that's when they change. But their incentive structure is crazy. So. All right, so Bitcoin is a relatively simple program. At the end of the day, it is transfer money from A to B with checks, right? So a transaction, as I said, is a very simple thing. From, to, amount, signed. If we extend that a little bit, Namecoin, does everyone know what DNS is? Yeah, DNS is the thing that basically resolves google.com into an IP address, right? Namecoin was set up as a distributed solution of DNS. It was the first fork of Bitcoin, right? The first copy of the Bitcoin code to be used for something else. And they basically extended the concept of Bitcoin slightly by saying, we can update, you can actually publish a contract that says from, to, and also update name, basically, right? There's a few more details, but it's, right, I want this name, right? So you could publish, I own usid.bit, right? .bit is the Namecoin domain extension. And then if you're the first person to do that, you own that domain. If I want to go to usid.bit, I look it up, I look up the blockchain, I see what you've published against that, and then I visit your IP address, right? The point I'm trying to get here is this is a slightly more complicated version of a transaction, but it's still limited. You can still only send money and do this, right? We want to take that a huge step further, and people did. There's lots of other forks, and they see this Dogecoin and Litecoin and all these other ones. There's slight changes and variations to the Bitcoin protocol, basically. Ethereum is arbitrarily complex. We extend the concept of a transaction beyond this rigid structure of X, Y, Z and allow people to publish code, a full Turing coding language in the blockchain, right? This has some really serious implications. I can publish, so if I write a bunch of code in their custom language, I compile it, and then I publish it to the blockchain, that forms what's called a contract or a smart contract. That smart contract, do I have a slide on this? No. That smart contract is effectively now its own independent, uncontrollable entity that is governed entirely by the code that was originally published. Because I publish this code, takes some input, has some storage, and has some output. I publish that to the blockchain, everyone can see that I've done that, right? Someone else can then come along and interact and send transactions to my contract. No one can then change that contract. That contract now exists on the blockchain forever, unchanged, so that anyone can read the code, you can trust that it's going to do what it's going to do, because it can't do anything that's not there. And I can't change it, so I can't take your money. Right, so this has all kinds of implications, and the surface is, we're only just scratching the surface, right? So one example that I like to give, it's a really simple example, and it's kind of dead now, to be honest, but it is a good simple example. It's called Lotto Polo, or chicken lottery, right? Basically, this guy wrote a contract, and the premise is basically he put 100 Ether in there. This contract has a balance of 100 Ether, which is the internal currency. And it says, right, if nobody sends me at least 1 Ether in a time frame of 24 hours, I will pay out my entire balance to the last person who put the money in, right? Pretty simple. It's kind of like that Reddit button experiment, right? It goes and goes and goes. Now, Ethereum's not big enough yet, so it didn't actually grow that far. It only got to about 32 days or something, and then it died. But it's an interesting concept. So I told this to my friend, and she's like, look, that's a scam. You're going to lose your money. What are you doing? And I said, you'd think that, but you'd be wrong. Because